So for the first part of the experiment, what we have to do is make 2 chromatograms and just measure the RF values. Now we can make chromatograms for a process called chromatography, paper chromatography. Chromatography is pretty much a technique used to separate the different components of a mixture. Now let's go over our materials. First we have our solvents, water and 99% alcohol. There are some coloring marking pens, toilet paper, 2 jars, a ruler so that we can measure the RF values, 2 pencils, and some tape. So to start off with, what we have to do is cut a piece of paper. What you have to do is cut a piece of paper. I'm just gonna take a bit of a long one right now. Like this. So now what we have to do is just cut a piece of paper and make sure it's just long enough so that it is touching the ground, touching the bottom of this jar. Let me see. It's a bit too long, I would say. To make sure that when hung over the pencil, the jar is just touching the base. So now what we have to do is just mark 2 centimeters above the bottom of this paper. And now we have to draw a line 2 centimeters above. So let's just draw it like this. Okay, now that should be complete right now. So now what we're going to do, we're going to take some of our coloring pens. I'm gonna take these ones, but it really doesn't matter, just as long as they're different color. We need to start at least around 1 or 2 centimeters away from the edge of this paper. So I'll just take 1.5. Now let's just mark it like that. And then from there, 1.5 centimeters away from the little red mark, we need to make another one. And then around another 1.5 centimeters away, we need to make another one. So around at 4. And the last one should be around here, I think. Yes. Actually, I think about, I think I did it a bit too far. Let me just, they actually do have good. So let me just cut this away. I have to do is just mark this piece of paper with the solvent that we're gonna use it with. For this piece of paper, we're gonna be using it with water, so let's mark it with water. And yeah, I think now what we have to do is fill up our jar or with the solvent I'm using. So let's make sure that the solvent goes around 1 centimeter of the jar. Okay, I think that is pretty correct. Now what we have to do is wrap our paper around the pencil, and just be really careful so that the paper doesn't fall into the solvent immediately. Need to be very cautious here. So I think I'm a bit too ahead. So I think this will be better. And now let's bring this on. Oh, I guess I should do it on this side so that you can see it more clearly. We need to make sure that the paper, we need to make sure that the paper is going to touch the solvent, but not be surrounded to the solvent. So I think that should be okay. Yeah, I think that is pretty fine. So now what we have to do is just wait till the solvent goes up. This process could take 15 minutes, but it could possibly take more. So in the meantime, what we can do, we can make our second piece of paper. Now I'm not going to go as in depth for making this, purely because it's the same process, but instead we're just doing it with alcohol. So yeah. To sort of explain what's going to happen now, the solvent, it will move up along the paper, and while it's doing that, the pigments will also move up. And now all we have to do is just wait till it gets to the top of the paper, and then we can start measuring the RF. So before we can calculate the RF values, we need to first understand what are RF values in general. Now, to put it simply, RF values are values which show how soluble a particular pigment is within a given solvent. In other words, the more soluble a pigment is in a given solvent, the more the RF value. Now, RF values are important because they help us understand how soluble a pigment is within a given solvent. So now that we understand the basic definition of RF values, we can now look. By the way, this is the paper I got out from doing it earlier. It was in horrible shape, so I made another one. The process was the same. It's just that this wasn't as satisfying, so I'll just put it away. So from here we can see that these pigments it's moved at different distances is even between each solvent. For example, in alcohol, the blue one moved way more, or when compared to the when compared in water. So RF values are different because different pigments have different solubility in different solvents. So now when we compare them, we can see that red it is more soluble in water since it moved a bigger distance, and we can see that the blue moved with a bigger distance in alcohol than in water, and yellow moved with a much bigger distance. It's when being submerged in water to the when compared in alcohol, and green it moved a slightly the bigger distance in water when compared with alcohol. So now it's time to actually measure the RF values. So first things first, we have to identify the point where the solvent stopped. Oh yeah, so to calculate what the RF values, we have to start from the baseline and then find the point where the solvent sort of stopped. And then how to calculate the solvent, we need to find the point where the ink stopped, and divided by the point where the solvent stops. We start with measuring from the baseline. So in here, the red one is kind of complicated. So over here, it's stopped around here, which is pretty much the solvent stopped right around here. So let us first try to measure that point. Approximately 13.5 centimeters. Now let's try to calculate. So now I just forgot how to take a piece of paper. But so let's see, the solvent approximately stopped at 13.5, and the red ink starting from here stopped around at 13.2. So the RF value for red over here is 13.2 over 13.5. Now let's compare it with, let's see the RF value in yellow. It's okay, so the maximum distance yellow traveled is 13, so and now for blue, it's kind of complicated since it's mixed in with the green. I'll just take this. So it stopped around 10 point, the blue one stopped around at 10.1 or 10.2. So now what we have to do is blue 10.2 over 13.5, and now the green one has stopped around 11.7, around 11.7. Yeah. And now let's measure the RF values in alcohol. So the point at which the alcohol stopped was around 11 centimeters. Well, actually around 10.5 centimeters. So starting from here, the red one solvent stopped. Okay. The RF value of red over here is around 7.1 over, how much was it? 10.55 centimeters. Now the RF value for blue is kind of complicated since it spreads so much. So now let me see. It stopped around God. The blue one is kind of hard to calculate. It stopped around where the solvent stopped. Weird. So the blue one is practically 1, I want to say. Now yellow stopped very early on, so it's around. So yellow equals 2 over 10.5. Now green sort of mixed in with blue over here. Stopped at around. It stopped around 8. So now we have. So now we managed to calculate all the RF values. I think that's about it. I think I've described everything. So now let's move on to leaf chromatography. So before we're actually starting leaf chromatography, we need to understand what it is. So throughout a year, we can see that we can observe that leaves change their color. This is because of the couple of coloring pigments. Now the aim of leaf chromatography is to separate these coloring pigments in the chromatography process. Now let us actually move on to it. So let's go over the materials. We're gonna need 2 small jars, a shallow pan. This is not quite shallow, but it should do. We need rubbing alcohol, we need coffee filters, a couple of leaves, and hot water. What we need to do is just cut some of these leaves into the small jars. What we have to do is pour enough alcohol from the leaves. Let's do this. Same thing for the next jar. So now the leaves should be covered in alcohol. So now what we have to do is fill up this shallow pan with at least 2 or 3 centimeters of hot water. So let us do that. That should be 2 or 3 centimeters. Okay, that should be 2 or 3 centimeters. And now what we have to do is just set the jars into a shallow pan. Oh god. The pan is not big enough. Got the second pan. Sent to repeat the process the second time. So So I think it should be more. So all we have to do is set our jar in there, and that's it. Now I have to wait around 30 minutes, but we also have to make sure to replace the water because it might cool. So now, these the jars are complete. I don't know if the camera can pick this up. They have officially changed their color. This one as well. So the fact that they changed their color means that they're completed, and obviously we got them out of the shell pans. So now what we have to do is just take our coffee filter and just start cutting long strips through the coffee filter. That's it. Now we have two long strips of paper. So now what we have to do is just put one strip of paper inside the jar. Yes, and oh god, I made the strip of paper not long enough. Now what? Now the other. Oh god, like this. I think that's good enough. And now with the other one, we should do the same. And so now I think it should be good. This is the result I got after about a week. I decided to try this experiment with normal paper towels as well. And after about a week, we could see that the alcohol managed to separate some of the pigments from the leaves. So this green color is mainly we can see the green color because the alcohol managed to separate chlorophyll from these leaves, and the red color is through a pigment called for pigments called anthocyanins, which are mainly produced in the fall for leaves. So on this we can see that the anthocyanins probably have a higher RF value because they traveled further along the paper when compared to the chloroplasts in these unfiltered papers. However, we can't even see the anthocyanins in the coffee filters. Maybe it's because of the differences in the structure between in these coffee filters and just normal unfiltered paper. So the reason why plants have so many different pigments is so that they can always absorb the maximum amount of energy from sunlight, no matter which wavelength. So now that I finished the experiment, I would like to thank you all for watching this video. And special thanks to my biology and chemistry teachers.